Hello students, welcome to the session. In this session we are going to see the exercise 2.2 first sum. Find the zeros of the following polynomials and verify the relationship between the zeros and the coefficients. So you have to find the zeros of the given polynomial and we have to verify the relationship between their zeros and coefficients. The relationship between their zeros and coefficients is sum of zeros is equal to minus of coefficient of x term divided by coefficient of x square. Then the product of the zeros is equal to the constant term divided by coefficient of x square. So these are the relations we have to prove. First let us find the zeros of the given quadratic polynomial. So I am substituting the value of the polynomial to be 0 for finding the zeros of the polynomial. Let us use splitting the middle term method to find the zeros of the quadratic polynomial. For that I have to find the product of the coefficients of the x square and the constant term. So it is 1 into minus 8. So I have to find the factors for the number minus 8 so that the sum of the factors must be equal to the coefficient of x term. Here it is minus 2. So I have to split minus 8 as minus 4 into plus 2. So minus 4 into plus 2 gives minus 8, then minus 4 plus 2 gives minus 2. So I am going to split this minus 2x as minus 4x plus 2x. Okay. Then taking x as common I will get x minus 4 and here taking plus 2 as common x minus 4. So combining these terms x plus 2 into the common term, here it is x minus 4. So x plus 2 into x minus 4 is equal to 0. Equating it separately, x plus 2 is equal to 0, then x minus 4 is equal to 0. So x is equal to minus 2 and x is equal to plus 4. These are the zeros of the given polynomial. So let us substitute alpha be minus 2 and the value of beta to be plus 4. Then comparing the given polynomial to ax square plus bx plus c. This is the standard form of quadratic polynomial. I am going to compare the given polynomial with this standard form. So I will get the value of a to be 1, the value of b to be, that is x coefficient, minus 2 and the value of c, constant term, here it is minus 8. So I am going to substitute these values, alpha is equal to minus 2, beta is equal to 4, a is equal to 1, b is equal to minus 2 and c is equal to minus 8 in this relations. Okay. Let us take the first relationship, sum of zeros, that is alpha plus beta. Here alpha is 1 0 and beta is 1 0. So alpha plus beta is equal to minus of x coefficient is b and x square coefficient is a. We have to prove this condition, alpha plus beta is equal to minus b by a. First consider the LHS. LHS is alpha plus beta. So which is equal to alpha minus 2, beta plus 4. So minus 2 plus 4 gives plus 2. Then consider the RHS. RHS is minus b by a, b value is minus 2, so minus b by a will be equal to minus of minus 2 by A value 1. So, which is equal to plus 2. Thus, LHS is equal to RHS. So, the sum of zeros is equal to minus coefficient of x by coefficient of x square condition is proved. Then go for the second condition. Second condition is product of zeros. So, product of 0 means alpha into beta is equal to constant term here is c and coefficient of x square is a. Substitute the values. Alpha is equal to minus 2. So, which is minus 2 into beta value here is 4. So, minus 2 into 4. Minus 2 into 4 gives minus 8. Then consider the RHS, which is C by A. So, C by A, which is equal to C minus 8, A value 1. So, minus 8 by 1 gives minus 8. Thus, LHS is equal to RHS. So, the second condition is also proved. So, the product of zeros is equal to the constant term divided by coefficient of x square. Then the second subdivision 4s square minus 4s plus 1. Let us substitute the value of the polynomial to be 0. Then using splitting the middle term method, I have to find the factors for 4 into 1 4. So, 4 can be splitted as minus 2 into minus 2. Minus 2 into minus 2 gives plus 4 and minus 2 gives minus 4, that is the coefficient of s. So, I am going to split 4 as minus 2 into minus 2. So, the term middle term minus 4s is splitted as minus 2s minus 2s. Okay. By taking 2s as common from these two terms, I will get 2s minus 1 and here I am taking minus 1 as common. 2s minus 1 is equal to 0. Writing this term 2s minus 1 and then writing the common term 2s minus 1 is equal to 0. Separately equate to 0, 2s minus 1 is equal to 0 and here also 2s minus 1 is equal to 0. 2s is equal to plus 1, s is equal to 1 by 2. Here also s is equal to 1 by 2. So, the zeros of the given polynomial are 1 by 2 and 1 by 2. Let me substitute. Let alpha is equal to 1 by 2 and beta is equal to 1 by 2. Then compare the given polynomial to the standard form of the quadratic polynomial. I will get the values of a to be, a is the coefficient of x square, here it is 4. Then b is the coefficient of s term, here it is minus 4. C is the constant term, here it is 1. So, I am going to use these values. Okay. Consider the first condition. Sum of zeros, that is alpha plus beta, must be equal to minus b by a. Consider the LHS alpha plus beta. Alpha is 1 by 2, beta is also 1 by 2. So, half plus half gives 1. Then consider the RHS minus b by a, minus b by a. Here minus b value is minus 4. So, minus of minus 4 by a value 4. So, which is 4 by 4, that is equal to 1. Thus, LHS is equal to RHS. First condition is verified. Then consider the second condition. Product of zeros, that is alpha into beta is equal to constant term is c and the coefficient of x square is a. Substitute the values. Considering the LHS, I will get alpha into beta. Alpha value is 1 by 2, beta value is 1 by 2. So, 1 by 2 into 1 by 2 gives 1 by 4. Then RHS C by A. So which is C is 1, A is 4. So C by A gives 1 by 4. Thus LHS is equal to RHS, second condition is also verified.